All right, for those of you who are not in class and need a little assistance on this assignment related to Hooke's law, I'm going to give you some input. So Hooke's law states that the force from a spring is equal to the spring constant times the distance away that it has been stretched. So number 21, we have pulling on a spring with a force of 1.2 newtons causes a stretch of 6.4 centimeters. So let's picture it. So I have the spring. It's sitting there at rest. So its equilibrium is, let's say, right there. And then I'm going to stretch it to some new value of x equals 6.4 centimeters. Well, who stretched it? I did with my force applied. So if I draw a free body diagram of me stretching it, force applied, which direction is the force of the spring? It's trying to get back to where it was. So it's push pulling to the left. So if they tell me that I stretched 6.4 centimeters, and I know the K value is 1.2 newtons. So let's write what else we know. We know K equals, I'm sorry, that's not my K constant. Let's back up. I know that the force applied was equal to 1.2 newtons, so they gave me that. If that's the case, the force of the spring has to be 1.2 newtons at that location because it's sitting there at rest, so those are equal to one another. And we know that the distance that it was stretched was 6.4 centimeters. I got to convert that to meters. 100 centimeters is equal to 1 meter. So it's 0.064 meters. I want to know what the K constant is. Okay, so what is K? So F of the spring is equal to K times X. And I'm looking for K, so I got to solve for K by moving X over. We know the force of the spring at that stretch is 1.2 newtons, and we know X is 0.064 meters. I have to convert those to meters before I do this, and I will get 1.2 divided by 0.064, 1.2 divided by 0.064, and I get a K constant of 18 we'll call it 8 Newton over meter. Okay. All right. Number 22. What is the stretch? How far does it stretch when you pull on with a force of 2.3 newtons on a spring with a spring constant of 19 Newton meters? So let's draw a picture. So I have the string or spring, oh my gosh, and I'm going to pull it. Here's my force of the pull or applied, whatever one you want to call it. And I want to know this delta X equals question mark. And so let's do a free body diagram. I have the force of the pull this way. I have the spring is pulling to the left. This they told me was 2.3 newtons. This has to equal 2.3 newtons to the left if it's just sitting there and it's not accelerating. So I know that force of the spring is equal to K times X. They want to know what X is. They gave us K of 19 Newton meters. So I got to find X, which is force of the spring, divided by K. So 2.3 newtons over 19 Newton per meter. Newtons cancel, meter, this will become 2.3 Newton over 19 Newton times a meter. Newtons cancel, and you get 2.3 0.121 meters or 12.1 centimeters, either or. Okay, that's what I know.